Hello, geometry students. Today we are covering lesson 9-2, proofs using coordinate geometry. Our learning targets are, I will plan a method of proof, using coordinate geometry. I will prove theorems using algebra and the coordinate plane. Our vocabulary for today is deductive reasoning, razonamiento deductivo, proof, prueba. For example 1, we are going to plan a coordinate proof. So we're going to plan a proof to show that the diagonals of a square are congruent and perpendicular. So we will start off by drawing a square with one corner at the origin, and then we'll just put these points and we will connect them to make a square. Oops. So with our square, we need to put some arbitrary coordinates. So if we go to this would be 0, 0. That's obvious, that's the origin. But if we go to the right, we will call going to the right a distance of A, and then we didn't go up or down. Now, if it's a square, the distance that we go to the right is also the distance we will go up. So if we look at this corner point, our coordinate is 0A, and this last coordinate point is AA, because we went a distance of A to each point. Now, we want to prove that the diagonals of a square are congruent and perpendicular. So we need to come up with a plan. So step 1, draw a square. And label points. And we're using algebra to label these points because we don't know what the actual numbers are, and if we use a variable, then we can prove this for any square because it doesn't matter what number we put into A, it will be a square. So step 2, our plan is to draw the diagonals. And then we have to prove that they're congruent. So we'll use to find congruent, we need the distance formula to figure out the distance between them and see if that distance is equal. So use distance formula. And that's to prove they're congruent. And we also need to prove that they're perpendicular, so we will use slope to show they're perpendicular. And then the next step is we have to carry out that plan. Okay, so the first step of our plan is to use the distance formula to show that they're congruent. And then we have to use the slope formula to show that they are perpendicular. Instead of labeling the points with letters, I'm just going to show that we're going to go from the origin to AA to figure out that distance. So the distance formula, if you remember, you can look in the poster, we are going to subtract the x values, so a minus 0. We're going to add And then we'll subtract the y values. So a minus 0, again, squared, and then we take the square root. So a minus 0 is just a. So a squared plus another a squared. That simplifies to 2a squared, square root of. Now we want to find the other distance to see if they are equal. So we're going to use these other points here and here. And we're just going to do the distance formula again. So we're going to take the square root. For the y's, if I start with this one, I have a and I have 0. So a minus 0, parentheses squared, plus, then we're going to have 0 minus a for the x's, squared. A minus 0 is a, and 0 minus a is negative a. But when we square them, we get a squared again, right? Because a negative times a negative is a positive. So they end up both being a squared. A squared plus a squared is 2a squared. Be careful, it doesn't equal 0. So that is showing that the distances of the diagonals are congruent. Now, the second part of our plan was to show that the diagonals are perpendicular, and we're going to use slope. So what is the slope from here to here? Well, the slope formula is the change in y over the change in x. So we have a is our y and 0 is our other y, and then a is our x and 0 is our other x. So that becomes a over a, and that equals 1. Then we have the other line. So I'm going to draw it in blue again. We have this line, and that is going to be the change in y. So the y's are a minus 0 over the change in x, 0 minus a. So a minus 0 is a, and 0 minus a is negative a, so this equals negative 1. Are these perpendicular? Is 1 the negative reciprocal of negative 1? And yes, it is. So we just proved that the diagonals are congruent and that the slopes are perpendicular of those diagonals. Okay? That is example 1. On example 2, we are writing a coordinate proof. Write a coordinate proof of the trapezoid mid-segment theorem. Given trapezoid ABCD with midpoints E and F, you can see those, I'll highlight them for you, E and F, those are the midpoints. Prove that EF is parallel, this means parallel, to AD, which is also parallel to BC. And also prove that EF, this distance, EF, is equal to AD, which is this distance, plus BC divided by 2. So basically what we're saying is that E to F is the average of the other two parts of the trapezoid. And that is called the trapezoid mid-segment theorem. All right, for step 1, we need to find the coordinates of E and F using the midpoint formula. And we can use that because that's the definition of a mid-segment, It's in the middle. All right, so we will find the coordinates for A to B. The midpoint of that is going to equal the x's added together. So 0 plus a divided by 2, and the y's added together. B plus 0, or 0 plus b if we want to use the same format. 0 plus b divided by 2, which simplifies to just a over 2, comma, b over 2. So that is the coordinate of E. I probably should have just written that in the beginning, so E. Then we're going to find the midpoint of DC, which will give us point F, right? So that's going to equal the x coordinates c plus d divided by 2 and b plus 0 divided by 2, which simplifies to just c plus d over 2 b over 2 in parentheses. For step 2, the slopes of AD, BC, and EF all equal 0. And the reason is because the segments are parallel to the horizontal. Well, actually, I'm so sorry. It's just they are all horizontal. So the slopes are all 0. Horizontal. Therefore, EF is parallel to AD, which is parallel to BC. So all of the slopes equal 0. That means they're parallel because they have the same slope. Step 3. Determine the distance of AD, the distance of BC, and the distance of EF. Since the segments are horizontal lines, the lengths are differences of the x coordinates. So we just have to subtract the x coordinates, right? So for AD, that is equal to d minus 0, which is just d. That's the distance. BC is equal to c minus a. Because if you look at the coordinates of B and C, the B's don't matter because that's just the height, and then we had C and A. And then the distance from E to F, we have to subtract the coordinates of E and F, and I didn't write those on our picture, so I'm going to write those now, but it's C plus D over 2, comma, B over 2. And for E, we figured it out to be, I used blue for E, A over 2 and B over 2. That's the coordinates that we just found for E and F. So the B over 2's are the same, but the C plus D over 2 and the A over 2 are different. So we're going to subtract those. C plus D over 2 minus A over 2. Since they're both over 2, we can simplify that to just be C plus D minus A over 2. Now we have to use algebra to show that AD plus BC over 2 is equal to EF. Okay. Which looks like it's true because if we substitute in D for AD and we substitute in C minus A for BC, because that's what they were. Oops. If we substitute these in, you would get D plus C minus A, and then we put over 2. And that is equal to what we got for EF. You just have to change the order of the C and D. And that is how we prove the trapezoid midsegment theorem. Nicely done.